right, hey there, Longhorns. It's Miss Campbell, and today we are going to cover how to prove that a quadrilateral is a parallelogram. So yesterday we talked about the properties of parallelograms. So we said, okay, if we already know that a shape is a parallelogram, then we can say these certain things are true, right? Today we're going to go the other way around. We're going to see, we're going to make some observations about the shape. And then based on that, we're getting evidence. We can prove that that shape is actually a parallelogram. So we're going to use evidence about a quadrilateral to show that it fits the attributes of a parallelogram. And then you can prove that it actually is one. So we're going to go on ahead and get started. The first thing that you will need to see, and you only need to see like one of these things, right? So it says if both pairs, okay, so both pairs of opposite sides of a quadrilateral, if they're congruent, then we can say it's a parallelogram. So if both of our pairs of opposite sides are congruent, then it is definitely a parallelogram. So if you see something like this, right? So in this one, the top and the bottom are congruent, okay? And then we see these, the left and the right would be congruent. This is a parallelogram, because both pairs of opposite sides are congruent. Okay, they could also put numbers for you. So like say this one's 10 and the bottom one would also be 10. This is 5 and this is 5, right? An example of where that would not be true is like, let's say that here we only have the top and the bottom marked congruent, right? And then maybe the one side is marked with 3 and the other one over here is 2. Well, the top and the bottom are congruent, but the left and the right are not. So this would not be a parallelogram. Okay, and then they could also do this. They might not even mark these sides. If they only mark the top and the bottom congruent, well, you don't know about the left and the right. So that would also not allow you to prove that it's a parallelogram. It could be, but we don't have enough evidence, basically. All right, next thing. It says if an angle is supplementary to both of its consecutive angles, then it is a parallelogram. So here, let's say that this angle is 100, right? If I go this way and this other angle up here, when I add it to the 100, if I get 180, okay, and then I also have to check the angle going this way, and I have to add these two angles and they should equal to 180. If that's true for both of them, then yes, we've got a parallelogram. So both ways, you have to go look at both corners that are attached to it. 100 plus 80 equals 180, and I'm going to underline this in green, so I'm going this way, okay, and then we'll do blue, talking about this way, okay, so if we do 100 plus 80, that's 180, okay. So if you go one way and you add them and they get 180, if you also go the other way and you add them and you get 180, then it is a parallelogram. So an example of it not being a parallelogram could be this, like let's say that this is 70, right? And this one over here is 90, and this one up here could be 90. Well, if I go this way, I do 90 plus 90, that's 180. Okay, that works out that way. But then if I go this other way here, I would do 90 plus 70, well, that's 160, right? Okay, and 160 is not what we need. So this would not be a parallelogram. And again, if they also don't offer you enough information to prove this, then you also cannot conclude that it's a parallelogram. Okay, the next way you can prove if a quadrilateral is a parallelogram is if both pairs of opposite angles of a quadrilateral are congruent. Okay, so both pairs of our opposite angles have to be the same. So I have to see the ones on this diagonal, they have to have the same markings or the same number. And then the ones on this other diagonal, they also have to have the same markings or the same number. So for example, these could be 100, right? And then these other ones, they'd have to be 80 because remember, our consecutive angles have to add up to 180. So these are the opposite ones here are 100. Okay. And then the other ones going this way, they're both 80. Okay, now a way that would not be able to prove it is if they only mark one. Okay, so that would be not enough information because you don't know about the other diagonal. Or if they showed, you know, like this had 2 lines and this had like 3 lines. Well, we have one pair of opposite angles that's congruent, but my other pair, they don't have the same markings, so they're not congruent. So this would not be a parallelogram. Okay, also, I'm gonna let y'all know there's a shortcut for, you know, instead of writing out the word parallelogram each time, guess what? You literally draw a little parallelogram, okay? So that's the shorthand for saying parallelogram is just drawing the shape. And again, y'all, with this here, the picture on the right, every time that they're trying to show you that something's not a parallelogram, it's not going to necessarily be presented like this. You have to kind of think, like, do I have evidence to show that both pairs of the opposite angles are congruent? Okay, like I said, they could show you all 4 angles and show that one pair is not congruent, or they could just, you know, leave information out too. Okay, next way. It says if the diagonals of a quadrilateral bisect each other, so both diagonals have to be bisected, then it is a parallelogram. So we have our one diagonal here, and then we have our other diagonal going the other way. If you're shown that each one is cut in half, okay, then yeah, that's going to be a parallelogram. Okay, so this is a parallelogram. Over here though, look, maybe they could just show us one diagonal, right? And then they'll give us this like center point and they'll say this is 10 and this is 10. But do we know anything about our other diagonal? No. Or, you know, let's say here they go and they say this is, this one over here is 12 and this part is 10. Well, is this second diagonal cut equally in half? No, it's not. So that's not a parallelogram. Okay, another way is if one pair, okay, one pair of opposite sides is both congruent and parallel. It has to be both. It has to be marked as congruent and parallel, then it is a parallelogram. Okay, so how do we show that they're congruent? Well, we put tick marks. How do we show that they're parallel? You can put arrows. Okay, so if you see like this, that it's congruent and it's parallel and it's the opposite sides, then that is a parallelogram. Okay, they might also tell you, I'm going to put some letters up here. So A, B, C, D. So they could also say that AB is parallel to DC. And if they told you that, then they wouldn't have to put the arrows. Okay, so remember this means parallel. So if they wrote it out for you like this, guess what you need to do on your picture? Draw those arrows in. Okay, now here on the other one, well, let's say that they show that this pair of sides is parallel, and then they show my other pair of sides is congruent. Are they showing one pair of sides is both parallel and congruent? No, they're not. Okay, so this one, you could not prove that it is a parallelogram. Again, it still could be, but based on the information they've given us, we can't say for sure. Okay, now we're going to do some examples. So our first example here, they're saying, is the quadrilateral a parallelogram? So what we have to do is we can see we're given angles. Okay, we're given two angles there, and clearly these are consecutive angles. So we're supposed to show that both of our consecutive angles are going to add up to 180. So I'm going to look at both sides of them here. So I'm going to do 107 plus 72. So 7 plus 2 is 9, 0 and 7 is 7. So we get 179. And then I also see I have the same two angles this way. So for this one, this is not a parallelogram. Okay, and the reason why is because our consecutive angles are not supplementary. Because remember, adding up to 180 means they're supplementary. Okay. Our next example, they say, is the quadrilateral a parallelogram? All right. We can see we have one diagonal, and they're showing us that that diagonal is being bisected because it's got two equal pieces, but we don't know about the other one. So on this one, we cannot prove that it is a quadrilateral. I'm sorry, we cannot prove it's a parallelogram. It's a quadrilateral because it's got four sides. But no, both diagonals are not bisected. So on your assignments, you see, we're having to give reasons. So make sure that you are actually like taking the ways that you can prove that something is a parallelogram. And then if it's not, you have to give like a description as to why. So for this one, it's no, because both of our diagonals are not being bisected. Or you could say only one diagonal is bisected, not both, something to that effect. Okay, now they're saying given that GE is 24 and GH is 12 and DF is 32 and HF is 16, we need to prove that DEFG is a parallelogram. Okay, so we're dealing with diagonals here. We need to show that our diagonals are being bisected, and we need to show that both of them are bisected. So remember, bisected means cut in half. So GE, since it's 24, half of 24 is 12. And so if we know that the total is 24 and I know that this piece is 12, well, then I automatically know the other piece is also 12 because, 24 minus 12 is 12. And also, if I know that half of 24 is 12, well, then that tells me this GH is half, so that means the other side is half. Okay, now let's also go the other way. DF is 32, okay? And so then I can do 32, and I take away HF, which is 16, and I do 32 minus 16, guess what? I get 16. So I know that both halves are 16. You could also say, okay, I know 32 divided by 2 is 16, and they already tell me one section here is 16, and that's equal to half of the whole length. So there we go. So since both of our diagonals are bisected, so DEFG is a parallelogram because both diagonals are bisected. Okay. So now we got this other example here. It says find the values of W and Z. Okay, we can see that W and Z are in these expressions and they're talking about angles. And we have to use what we know about the angles on parallelograms, and they're going to tell you that this is a parallelogram. Okay, they're going to say, what do the values of W and Z have to be so that ABCD is a parallelogram? We know that our opposite angles have to be congruent to each other. So angle A has to be congruent to angle C. Okay, and then D has to be congruent to B. And then we also know that our two consecutive angles, okay, whichever way you go, they have to add up to 180. Now, you have to think about how you can prove it. Okay, look, if I'm going to do consecutive angles, I'm going to do A and D, right? Well, angle A is talking about Z in it, and angle D has W. So should I take the approach of adding the consecutive angles and seeing if they equal 180? That's going to be a little messy. What if I instead look at the opposite angles? We'll look at A, it's 7Z plus 5, and look at C, it's 8Z minus 10. Z with Z, that kind of matches a little better. And then how about angles B and D? Well, they're both dealing with the variable W. Okay, so if I'm going to have to prove that this is a parallelogram, take the easy way. Use your opposite angles, okay? And we can do the opposite angles here because they've given us all 4 of the angles, but sometimes they're only going to give you 3. And so then you're going to have to say, okay, I'm going to have to prove my opposite angles are congruent, and then I do my consecutive angles out up to 180. But since they've given us all 4, don't make yourself work harder than you have to. So angle A should be equal to angle C. So 7Z, make this look a little more like a 7. 7Z plus 5 should be equal to 8Z minus 10. Okay, so now we just solve for Z here. I'm going to add 10 to both sides. And then I'm moving the 7 over to the 8 because I moved the smaller one. Okay, so those all cancel. So I get 15. And then if you do 8Z minus 7Z, you get just Z because it's 1Z. So Z is 15. Okay, very good. And then now you really have 2 options. You could plug Z in here for like angle A and then do add angle A and D and set that equal to 180. But again, don't really make yourself work harder than you need to. Just set the opposite angles B and D equal to each other. So we could do 3W plus 10 is equal to 5W minus 30. All right, so now let's solve. We're going to take the 3W over, and then I'm going to move this 30 to the other side. Okay, and so 5W take away 3W, we get 2W. And then 10 and 30, that's 40. So if you divide by 2, you get that W is 20. There you go. And if you want a way to check your work, well, you can always plug in Z and W, and then make sure that your opposite angles are actually congruent, and then make sure that your consecutive angles, they would add up to 180. All right, y'all. So that's all there is to it for proving that a quadrilateral is a parallelogram. See you guys in the next one.